Hello, everyone. Thanks for taking the time to join us this afternoon. I appreciate so many of you hopping on early. That's fantastic. We're going to go ahead and get started with today's session, Connecting Your Branch Offices Using Aruba SD-Branch. And our presenter today is our SVP of Engineering Services, Charlie Kohler.
Good afternoon, everyone. Thank you all who have joined us before for our series, and thank you and welcome back. To all the new people, thank you very much for joining. I wanted to do this one a little bit different. Just so you all know, we do have a special guest today, Will Smith. He is the Consulting Solutions Engineer or Systems Engineer for Aruba Networks, an HPE company here in Southern California, or I think more now the Southwest. So Will be jumping in and out through the conversation with me here today, and he'll help us walk through the interface later today as well. So we'll go ahead and get started. Quickly, just to go through some housekeeping stuff, you can see we're going to go from about 3:30 to 4 o'clock talking about what the product is, what problems there are with SD-Branch, or what problems the SD-Branch solves. We'll look at the basic architecture, and then we'll look into the interface on how that looks and how it's configured. Then obviously, as we do all of our web sessions, it looks like I'm not sharing my screen. All right, so sorry about that. So at 4 o'clock, we'll do an open session for questions, talk about anything that anyone on the call wants to talk about. So I'm gonna go ahead and get started. So I want to share this slide just because this is a common slide that we've shared across this entire series. We wanted to show that the Aruba Networks really is a platform, and it has multiple different ways for connectivity into your corporate environment, or while you're on your home branch office or any of your offices. So again, this kind of shows here the core of the network. This is your headquarters site or your data center, however your company is configured. You have your mobility master, which is your primary source for configuration. Then you have your mobility controllers, which is where users terminate and tunnels terminate. Those are set up in multiple different ways. The controllers, some could be a VPN concentrator, which is one of the ways we are going to talk about it today. You'll hear me reference the word VPNC. So that is a VPN concentrator. Then we have the virtual controllers, which is the IAP clusters, which can create a VPN tunnel, an IPsec tunnel back into a headquarters and drop off at a controller. VIA is one of the ones we talked about as well. This is the virtual intranet agent. This is a client that can run on your mobile devices, so your laptops, your desktops, your iPhones, your Android phones, your tablets, and it can, again, auto start your session for the VPN based on a response coming back from the controller if it's inside or outside of your network. In a trusted network or in a remote access points, which was the topic of, again, of our other sessions. This is very similar to the VPN from the virtual cluster. You have a single access point that creates an IPsec tunnel back to a controller in your DMZ and broadcasts your same SSIDs and gives wired access if you desire, with the same security as you do on your same corporate network. The one we are going to be talking about today is our branch office controllers and how it can do SD-WAN, and how Aruba Central is going to play into that. So some of the problems that we see today is that we have a huge proliferation of devices within the network. You also have device sprawl. So the number of devices you have to put out at a small office to be able to get it to connect up to the corporate environment. Take, for example, you spin up a new small site for 10 people. You need to put a edge router out there. You need to put a firewall out there. You then need a switch behind that to be able to give enough ports for your users. Then you need to provide wireless for it. So you have a minimum of 4 to 5 devices that you need before you can actually go through and have connectivity, as well as you then have to use dedicated circuits or do complex things like dynamic VPN or different IPsec site-to-site tunnels through your firewalls or your routers. So it makes it a little bit more complicated. The other hard thing about this is if you're doing private WAN, MPLS, you are going to have a much higher cost than a commodity internet that is out there. So we want to be able to go through and find ways to be able to decrease our costs and our number of devices, but increase our security as well as our overall availability and success at those sites. Will, feel free to jump in at any time. You're more than welcome to unmute yourself and jump in on any of these slides.
Yeah, no, you're doing really good. I think the only point I'll make is that, you know, as we go through this, like you were saying, Charlie, that a lot of the SD-WAN piece is somewhat new for Aruba, but a lot of the technologies that we're using are things that if you're an Aruba customer or have been an Aruba customer, you're used to, like user roles and those policies. And we're also reusing basically the same hardware. So it's really just the SD-WAN piece that we're layering on top of a lot of the existing technologies.
Yeah, and I would say that's a great point, and a lot of that actually comes from the central and the orchestration that you guys are able to do on top of that. But like you said, you guys are reutilizing a lot of the technologies and pushing them into the next level. So challenges with current distributed architectures, like we were talking about, complexity caused by increasing number of devices, so the number of VLANs that you have to put out there, the number of endpoints that are going mobile. So no longer do you have just desktops sitting at these branch offices or these retail locations. 90% of the time and 90% of the devices are probably more likely to be a handheld device. And with the way things happen today and the way architectures are built in those, it's very hard to have visibility into those branches. And when you look at MPLS, for example, we have issues looking at authentication and all the different pieces there. So on the WAN side, we go back to the MPLS, the time that it takes to spin up MPLS circuit, and the limited capacity and the cost that happens with it. So you lose all control of your routing. Well, you don't lose all control of routing, but you lose a good portion of your control, and you're reliant on the MPLS cloud to be able to determine your routes. You're able to set your routes within it, but you're still very reliant on the carrier to help with that MPLS. There's very complex management. So the other great thing that we're going to talk about as one of our key differentiators is the SaaS traffic, being able to put traffic directly up into your SaaS environment and be able to get that directed over the internet. So the other big challenge is when you're doing MPLS, you're just a layer 2 link in most layer 2, layer 3 link for that site. And so you have that lack of security, where when we talk about the SD-WAN, SD-Branch product for Aruba, or solution, not product, because SD-Branch is not a product, it is a solution. We will be talking about how we can actually increase that security. So the operational challenges for a site like this, when you think about it, if you're going to have a router, a firewall, a switch, and wireless, the odds of all of those being the same vendor and having a single point of management is very low. So that's one big thing that we're going to talk about, and how all of the pieces that come together in SD-Branch are all manageable through one interface using Aruba Central. So the goal for SD-WAN or SD-Branch is to simplify the branches, make sure that we can turn up sites very quickly, make it transport independent, meaning it doesn't matter if we have a ISP or a DSL line, if we're running T1s, if we're running commodity internet, if we're running private MPLS, we still can. That's not a problem. So we could use any type of internet. We could even use LTE as a backhaul for these sites. So we can spin up sites very quickly. And the next thing that we'll talk about is that common policy and management for wired, WLAN, and WAN. So we'll jump in here and we'll talk about all the pieces that make up Aruba's full stack solution for SD-WAN/SD-Branch. So your typical SD-WAN is going to be a head-end gateway, your branch gateway, and one of the things that I think is very interesting is the virtual public cloud gateways. So being able to spin up a gateway within your Azure instance, your AWS instance, your Google Cloud instance, and being able to run there and actually do your route orchestration and your connectivity back to your corporate environment very easily and quickly. So what makes it the SD branch is when we add in behind there the access switches, the access points, and we add ClearPass on top of it to do a unified policy across the entire platform. So cloud managed branch gateways are great. They're very low cost in a number of these devices. So the 7005 that you're looking at here and the 9004 that's on the top here, those start off at about $1,500 list price. And those give you up to 4 gigabits of throughput on that at those cost points. And the great thing is you do not get charged by the amount of bandwidth that's being brought through your SD-WAN. It's just the capacity of your circuits as well as the capacity of the boxes that are at the site. That's very different than a lot of the SD-WAN providers that are out there where you say, I have a 50 meg circuit, I'm going to charge you for that 50 meg circuit and the hardware to support that. And when you burst, you're going to have extra costs above that. That doesn't happen here. If you have MPLS and dedicated business class internet, and you're bursting above your CIR, your committed information rate, that is where you will see those charges, but that is not due to the SD-WAN. That is just due to you bursting above your committed information rate. One of the great things here that I think is a big differentiator here too as well is we are able to do up to 5 LAN ports on one of these devices. So I could take 5 different connection points. So I could take a T1, I could take a commodity internet, I could take an MPLS, I could take a cellular and a second commodity internet, connect all of them. And we'll talk later on about how we can actually do dynamic path selection and determine which traffic goes across which links. So take, for example, you have a hospitality location. You want to have a ISP that's commodity just for your guest users, that's direct internet access, but you want all of your corporate traffic to go across a commodity link, but using SD-WAN to communicate back to your corporate office. We can separate that traffic. That way the guest users do not use any of the traffic from the corporate WAN link, giving you a much better experience and control over the bandwidth that you need to utilize. Will, is there anything that you would like to talk about in this section?
Yeah, that's a good point. I think the other piece too, I mean, obviously, the whole reason that we're talking about SD-WAN is because, customers are realizing that these Metro E and leased line circuits are expensive, and you can get a better service in many cases by just utilizing an internet, a standard business grade internet circuit. So, obviously SD-WAN helps solve that problem, but it wouldn't be SD-WAN if it wasn't something that would be easy to deploy. And I think that's something that hopefully we can show during the demo, but the fact that you could take one of the gateways, drop it into a site, have it automatically talk to central, find out what group it's in, get its configuration pushed down. I mean, the idea being you can really drop ship these and have smart hands or someone just plug them in.
Yeah, and we do have a slide on that in 3 slides, so that's perfect. So SD branch architectures. So we kind of want to talk about that micro branch, a small branch, a medium branch, and a large branch. So a micro branch, think about it where we're basically going to do that virtual controller solution that we talked about earlier, where it creates a tunnel backup into your gateway, so your VPNC, and is able to sit there and communicate that way. That's your micro branch. You don't have to have a branch gateway. You're just going to use your access points that are instant or using the instant mode, and that will create a virtual tunnel backup and create your access there. Your small branch, you're going to go a step further. That's where you're going to actually add in that branch gateway, and you'll have APs behind that. They could be instant as well, and you'll have switches behind there. And that's where we're going to be doing manual and orchestrated route overlays. Then we look at the medium branch. This is where we're going to add redundancy. We're going to have 2 branch gateways at the edge, and they will create redundant tunnels up to the SD-WAN overlay. Then your large branch, you're going to have much larger boxes, and then you're going to have a router beneath that, and then your devices behind there. Is there anything you want to talk about on this slide, Will?
No, just that, I think what I've learned, at least doing a number of POCs, and actually we've had some success in some different deployments, is that there's not really one size fits all. And that's kind of the beauty of the solution, is that, based on the size of the gateway, and then we can obviously size the VPNCs correctly, you can mix and match. And so, not every every deployment's going to be cookie cutter. And I think the idea here is that our solution will fit across any one of those types of deployments.
I agree. And the great thing, it doesn't matter what size it is, it's still that same management platform. All right. So the power of Aruba's SD-Branch solution. We're going to talk about the simplicity at enterprise scale, optimized branch experience, and embracing the zero trust security. These are three big things that I find when talking to companies that have distributed environments. They want to make sure that it's simple and easy to scale. They want to make sure that they can monitor and know what's going on and make decisions based on what they're seeing in that. And the big thing that's out there today is that zero trust, that what I like to call coffee shop IT, where it doesn't matter where you're at, you still have that same security and that trust, because you can't rely on a border firewall anymore, because a personal device, an iPhone or an Android phone, you could take it out of your environment and you have all that data still sitting on your device. You got to secure that device and its connectivity to the internet. So having a solution like Aruba SD-Branch to be able to overlay everything and continue that security is huge. So that simplicity and enterprise at scale goes back to that single pane of glass. We're going to use Aruba Central for policy definition and branch enforcement. The orchestration, like I was talking about, for SD-WAN as well as the routing. We're going to use it for all of our troubleshooting. And to what Will was talking about, we can actually send these devices out to a site, and via installer app, we can actually give a person permission only for that site, even where they are able to scan the box or the serial number on the back of the router. It would tie it to their group within Aruba Central and their instance, and that would then download its configuration, give it connectivity, and we're up and ready to go on site. So think of large retails out there, large fast food companies. To be able to get to a scale of being able to do up to 500 sites a week with minimal amounts of teams, using this installer app is a huge benefit, having that zero touch provisioning. Will, is there anything you want to talk about at this slide?
No, I think that's obviously a big key component of this, is to make your lives easier, right? I mean, you know, as we start transitioning to different types of connections and uplinks, you know, moving from MPLS to internet and cellular based, you know, the whole solution has to be easy. And I think that's one of the reasons that we've been winning a lot of these deals, is because that deployment option, the way we handle the setup of the gateways is pretty simple.
Perfect. So optimized branch experience. So here's where we kind of take a look at, talk a little bit about dynamic path steering. We'll look at the contextual policy for WLAN and WAN. So this is where we're able to sit there, set SLAs, which is what we can do within the dynamic path steering. We can actually set SLAs to say, if we see jitter get beyond X, if we see latency get beyond X, we can now reroute our voice traffic over to a secondary link that has better quality of service, and make sure that the users there don't see a degradation. So I'm going to expand this out. So we're also able to use things like the user experience insight sensors, what used to be Cape networks. We are able to use that to actually go in and feed some data and monitor remotely what's happening at these sites to make sure that they are up and operational. Will, anything before I move on to the next slide here?
Nope, you're good.
Okay. So embracing the zero trust. So deliver upon your zero trust security methodology. It's really sitting there talking about making sure your edge is application and user aware. You can't get away with IPs and ports anymore. It just doesn't work. Looking at dynamic segmentation, that is a big thing, and that's where in my opinion, Aruba really separates themselves from the rest of the market. Most of those SD-WAN providers out there aren't going to be able to talk to you about dynamic segmentation and being able to have a single pane of glass that looks at that role-based IDS, IPS, role-based access, being able to sit there and put an IT user in the IT VLAN and give it different rules based on if it's a personal device or a corporate device, all from one platform. So being able to go and do that really gives you that zero trust in my mind. So we're also able to sit there and do integrations with people like Checkpoint, Palo Alto, and Zscaler, where we can take a branch gateway, and for Checkpoint, we could do CloudGuard Connect or CloudGuard Edge and point it to there via a tunnel, and we would be able to use a cloud firewall if you did not want to point it back to a corporate environment with a firewall at that point. Same thing with Palo Alto. Zscaler, we can do it there as well. We can put the tunnels up to Zscaler and write all of our policies within Zscaler, and we would put traffic into there and rely on that for traffic. Will, would you like to add anything here?
Yeah, that's a good point. I think these are the main ones that we integrate with as far as the cloud security providers. But what we've done, and this is fairly recent, we've built a framework for that. So there's even other ones not listed here that we can integrate with. The whole thing is we've basically built the structure so that we can apply policy and say that things that go to the internet before you let them go to the internet, they go across a tunnel to these cloud security providers. I think that's important for like what Charlie was saying about securing the endpoints because they could really be anywhere.
Well, and you bring up another good point there. One thing that I value quite a bit with Aruba is that they are very open with their integrations. They're not saying that you have to have 100% their products to be able to get a full feature set. They are willing to know that you need to go best of breed, and you're going to have different players out there that are going to do different portions, but they make the integrations very easy, simple, and secure. So the role-based policies for the LAN and the WAN. So we're able to sit there and look at everything just like you would at your corporate environment for the LAN. The WLAN, the switching, we're able to take ClearPass and enforce policy based down to it. And we're able to then talk to, or have that information talk with Central and determine when we have a QoS tag, what path it's going to take, what dynamic path steering we're going to use. So for security policies, we're able to talk about the firewall like we were just talking about on the last slide. Web content filtering. So looking at things for guest, PCI traffic isolation, being able to sit there and really know what's on the network and be able to create policy based on device and not just user and not just IP addresses. Being able to take it over and give you an overarching security policy. And then again, we're going to talk about the WAN policies. We're going to beat it to death. We're going to talk about the path steering policies applied per role, and we can do it per type of traffic. So it doesn't just have to say all guests go to the internet via another path and all PCI traffic goes to the MPLS. We can say PCI traffic goes across this MPLS because it's talking to this box. But PCI traffic or traffic from that same box that's not PCI related can go down a different path to a different secure path. Granted, PCI traffic, you're going to want to put all one path, so that might be a bad example. But same thing kind of applies with the desktop. So you want internet to go straight out for a user at the site, but you want anything that talks to the intranet to come across a certain link. We can define that there. Well, do you want to talk about anything there?
Yeah, just another thing I'll mention. I mean, I recognize a few names on the call, and I think some of you are familiar with what we do today on our campus deployments with user roles, and it's no different in SD-Branch. The only thing that we're doing differently here is that we take those same user roles and policies and we use it to influence how the SD-WAN traffic is reflected. Right, so you can apply different policies and we just tie it back to the same user role. So you're still talking to ClearPass, you're still, having your policies and firewalls rules pushed down from ClearPass, but we're using it to make changes to how we turn that traffic over the SD-WAN.
So this is one of the things that kind of what we were just talking about, where we have traffic coming from a branch and we need it to go to internal networks. We'll go across the SD-WAN overlay, come into the data center, we have the VPNC there. Say we're going to AWS, Azure, or Google Cloud. We can do an SD-WAN over there and hit a virtual gateway that's running over there. Or we can actually go in and do SaaS Express, which is the new word that's being used for a configuration methodology in here, which shows that we can actually take traffic that is meant for Office 365, Salesforce, any of your SaaS-based applications, and send it straight out a path to the internet and give it more direct access to those applications. I'm gonna jump over to our next slide. This kind of talks a little bit more in depth about that dynamic path selection. So this kind of talks about to what I briefly touched on a couple slides back, looking at that role and application. So that role that Will was just talking about, so we add the role plus application to determine, or to then add SLA. So say we're IT user or an HR user, for example. Let's go with HR. We're looking at Salesforce and we're trying to communicate out to some users and looking at everything. We start to see that there's a bit of delay, jitter, or traffic or packet loss. We are now going to change our path. Say originally we were going out the 4G link because it was our best one at the time, but we start to see more jitter. We're then going to move it over to the internet link and be able to sit there and say, we now think this is our better link based on our SLAs, and be able to get better user experiences. Well, would you like to talk about this slide a little bit?
No, I think that's it. I mean, the idea here is basically just being able to put SLAs in so that no matter where the traffic's going, we'll monitor each link, and we do different ways we can monitor directly to where you're going, because the idea is maybe you have a better connection to something like Slack via whatever ISP is appearing versus another, and so we can set up SLA so that no matter what the traffic is, it always takes the best path when it's internet facing. If it's go ahead, Charlie.
I would say Slack's a good example. Say it was supposed to go across your MPLS because you think you have a better internet link there, but your direct internet provider on your internet one has a better link. We can actually force traffic out the internet instead of MPLS, even though it's internal traffic or traffic that you would normally take across your MPLS. Sorry, Will.
Nope, good. That's good. Thank you.
So this just touches very briefly onto the cloud security integrations. So all it's really doing is showing that we can actually do a policy-based route to what we were mentioning earlier. When we come to the gateway, we can determine if we're going out to a VPNC, so back to the corporate office, or if we're going to send it into one of our cloud security providers. And we mentioned another one here, we add Symantec, because they're also another gateway that we can actually send traffic up to. So this information that we send up there is going to have information like their role, their VLAN, and their user IDs. So we can actually still do some of that user identification at those levels. All right, so now we're going to jump into Central. Will, would you like me to share my screen and we can go through a customer, or would you like to share your screen and go through an eval there?
If you have yours available, I don't have mine up right now.
There we go. All right, so this is a small customer of ours. So this is a very simple installation, and we'll make this a quick review since we're getting close to our 4 o'clock time. But we have two gateways. We have our VPNC here in Southern California in Poway, and gateway out in Las Vegas. We're able to spin this up, Will and myself, within maybe an hour and a half, 2 hours of time. I think our biggest issue was we were told one thing from Cox, being that it was going to be a static configuration or a DHCP configuration, but it turned out to be static. And Cox also had given our IP space away to another customer. So that was our most difficult part of running through this. So we're able to go in, get a very good view of what's going on within an environment. So let's click into the Las Vegas gateway. So this will give me a little bit more in-depth information about what's going on. So I'm able to get the information, the system IP address. That system IP address that we're seeing here is actually that internal IP address for the tunnels that are being brought up between the VPNC and the SD-Branch sites. So this gives you your information about code versions, and the great thing is it's telling you that you have a code version available, and all we have to do is click onto this. It'll upload the new code to the box and reboot the box. So very simple, very easy to manage. So you're able to talk about the groups. Groups are a way to push down standard configuration around a number of groups that you have. So you want to say the West Coast branches all have the same kind of configuration, the same SSID or same IP scheme, same everything. We could do it at the group level and then push it down. Then we can look at labels. We don't have any labels on this guy, but we can look at WAN availability. So, and again, we're looking right now at a 1 day period. We can go back and look at a 1 day, 1 week, 1 month, or 3 month period here. So let's go to a 1 month, and we can see that we've still been 100% good for there. I'm gonna go to 3 months because I know that we've had some issues out there on this site. you can see here, we had less than 50% uptime back on April 5th. What we know happened there is we actually lost internet from the internet service provider, and this site only had a single uplink. So we were able to see how everything was going at that time. So we can look at not only the WAN availability, we can look at the VPN availability, make sure that that's all up and going. We're easily able to see the amount of traffic that is being pushed across throughout the day. So we look at all traffic, internet traffic. So we can see the traffic going out to the internet as well as traffic coming across the VPN. So across the tunnels between the two sites. So you can see we're not doing much compression across the link here right now, but we can also see the health status of those links. So we'll go up here and look at WAN. You can actually define any of these 16 interfaces that are on the box that we're using out there as a WAN interface or LAN interface. Right now, the only one that we have defined as a WAN interface is GE00. And then we also have an LTE, but we don't have an LTE port plugged in. So we can look at the availability, we can look at the throughput again, and then the WAN usage is the same kind of thing. The LAN, you can see the ports that are defined as WAN, LAN, which ones are up, and then you can look down here and see what VLANs are associated with each one of those links. So you can do them as trunks or access ports and be able to push all that information out to them. So you can see here we are actually acting as the gateway for this 10.250.10.0 network, and that's the users that are out at that site. So you can then see we're also doing DHCP from this box. We are able to go through and see how free the space is. So we got 225 addresses. We're using 84%, or we have 84% of that free. So we can see the active leases that are in here, and we actually have identity going on here, and we're actually able to see the computer names and everything that are going across. So it's very nice to be able to say, okay, we got a David's PC. We know that that's computer, its IP address is 215. We have its MAC address. I can actually click on that MAC address and actually gain more information about what they are doing. Look at their connectivity, how much traffic they've been doing, all of that kind of stuff. You can see this person's currently offline, so we're not seeing any traffic right now.
Yeah, and I think that's if you don't mind, Troy, I think that's a good point, because one of the key features in the Aruba Central offering is the fact that we're tying everything together. So if you have our switches, you have our gateways, you have our access points, everything is in one place, and you can see that sort of troubleshooting tree. So if a user calls in and says they're having issues, you can look up that user, you can look across all the products and see if any of them are having issues.
Sorry, I'm just going back. So then we are able to look at our tunnels. So these tunnels are what's actually coming up and creating the site-to-site connections. So we're able to quickly, easily see what's going on here, the amount of traffic that's going across it. I'm gonna take this back down to a 1-day session, just so we have a little bit easier to see across what's going on in a single day. So you can see what's going on, how long the box has been up, the peer IP address at the far side, and then you can see that we have no packet loss. We can look at the jitter. So this is what is going to be used when we're talking about those SLAs that we were mentioning earlier. We can actually do integrations directly into your Skype servers or your call centers and actually help pull some MOS scores as well, which can be used to do the same kind of thing and change our SLAs. There are some built-in testing that they do to determine their MOS score without having to do integrations, and that's what we're using here today. So we can go here and we'll take a look at the routing. Again, this is a very simple network that we're going to be looking at. So we can look at the route table and we can see, so we're on the Las Vegas gateway. So the only network that lives out there is 10.250, or the connected network, which is right here, 10.252.10.0/24. But you can see we're learning the network, which is sitting behind the VPNC, the 192.168.0 network, and that was all added to the branch gateway over in Las Vegas using the overlay routing that's coming up. And you can see there's a number of different routes that are coming up. These static routes that you're seeing here are default gateways for Cox internet connection, and then we also have our VPNC connection here.
I think that's an important piece, because having done a few of these deployments and been in some of the POCs, you have some SD-WAN vendors that are very simplistic, and you have other ones that are, take it's more complex, approach, and you kind of question what's the benefit to having SD-WAN. And I think where Aruba sits is, this is a good point, that we kind of sit in the middle of that. We've tried to make it as easy as possible. Like, so for the example of learning the routes at the branch and being able to redistribute them back to the VPNC, in some cases we've done these POCs, it required you to spin up a whole BGP instance and do all kinds of crazy routing. This, to be honest, is BGP under the covers, but the configuration couldn't be any simpler. You basically configure the subnets at your branches, and you tell it to redistribute over the overlay, which is what we've created here. Yeah, exactly.
That's all done by the overlay route orchestrator.
Yeah, it's literally like 2 clicks and you can have it all set up. It's really easy.
So if we want, I can actually go here and hit config. We're in so we can look here at the routing. So you can see some of the routes that we're able to do. This is where we would configure the policy-based routing that we were talking about, telling different ways to get out. Next hop, if it's this type of traffic, send it out this path. Here's the OSPF configuration that Will was talking about. So we can look at our route maps. We can our redistribution, what VLANs, what IP subnets we want to move across, and then overlay routing. So we can also take a look at the WAN, and this is the very easy, simple way of looking at it. So I can click here, give it a name, test. So we can say source anything application, let's say application, and let's say YouTube. Of course, it's not wanting to work with me. So
it's a long list.
Yeah. So we'll hit save. So now we're going to go next here. So we can set SLAs. So we can say, I set YouTube, so we can say high availability. So we want to make sure it's always up, or let's do best for internet. Here we can sit here and tell what our latencies are, what we want our jitters to be. We can hit next, and then we can tell it, we want this to go across uplink 1. We want our secondary path to go out LTE. So if our SLA is not met on uplink 1, it's going to move that traffic over to the LTE links. So it's very easy. That's how quick it is to go through and do a dynamic path steering for an application. So I want to make sure that we showed that today. Will, is there anything else that you want to look at?
Yeah, I was just going to say, if you're on that same page on the uplink, I think that's the other piece to highlight under VPN.
Uplink.
Okay, sorry, yeah, you're right there. You're right there. So there's sort of 2 things that are happening under the covers. We call it's our orchestrator. We have a route orchestrator and a tunnel orchestrator. What Troy was showing was the route piece. But before that's even set up, what we do is we create the tunnels. And for this instance, it's not very exciting because it's just one uplink. But you can imagine if you've got a Metro E circuit, and then you have a backup internet, maybe a 4G, that's 4 different tunnels that you'd have to, or excuse me, 3 different tunnels you'd have to configure. All you have to do is come in here, label, port 1 is uplink 1, port 2 is uplink 2, and tell it which VPNC, or which headquarters data center you want it to go back to. And it'll automatically build those tunnels. And if it's internet-based, it'll build a tunnel from each internet uplink. If it's something like an MPLS, it knows it can only get to the VPN concentrator, the controller that's in the data center that has that MPLS link. So it's really, to me, this part's really easy and to set up, because if you've done this with any other previous, without SD-WAN, you'd have to manually configure the tunnels. There's no rekeying, all that stuff is all manual. This takes care of all that.
Yeah, and I was just showing here the link type. You got the MPLS, the internet, LTE, and Metro E, like you were talking about. And then you'd go in, tell it what VLANs you want to have across it, and the speed of the link, so that we can actually monitor utilization of that link. So we know when we're getting, so you have a 10 meg link. When we hit 9 megs, we know that we need to start looking at other paths and looking at that utilization. All right, well, I think I am going to stop the presentation at that point, unless there's anything else you feel we need to show, Will. Just since we're about 11 minutes over on the
normal. No, this is good. Yep.
Okay.
Thank you for watching our webinar replay. We hope you found the information helpful. The Surevera team is ready to assist you with any follow-up questions or needs you may have. To get more information about our upcoming webinars, join our email list from our website or follow us on social media. You can also access all of our existing webinar content on our website and social media channels.